What's scarier than a supermassive black hole? How about one on the run? A supermassive black hole ejected from the center of its galaxy at over 3.5 million miles per hour and leaving a trail of newly formed stars in its wake. At least that's what one research group of astrophysicists think is responsible for this faint line of light first seen in an image taken by the Hubble Space Telescope in 2022. But now there's a big scientific debate raging about whether that's actually what this fuzzy smudge is, with another research group claiming that it's not a runaway supermassive black hole at all, but instead just a very thin, flat galaxy that we're seeing from the side, edge on. And now we've got new data on this weird object from the James Webb Space Telescope, which has just added more fuel to the fire on both sides of the argument. So what is going on here? Well, in this video, we're going to dive into all of this scientific debate, starting with the unexpected discovery by Hubble and why people think this is a runaway supermassive black hole, and then why people think it's an edge-on galaxy instead, and how we'll find more of these things in the future. Plus, this is my area of expertise. My research is on supermassive black holes and the shapes of galaxies. So I'm also going to tell you which explanation my money is on towards the end of the video. But first, let's start with the serendipitous discovery of this thing that's been dubbed RBH1. Serendipitous meaning it was found by accident, like no one was actively searching for things like this. In fact, Van Dokkum and collaborators had actually applied for time on the Hubble Space Telescope to study dwarf galaxies that appeared to have no dark matter. But in one of the images they got back from the telescope, they spotted this long, thin streak that looked like nothing we'd seen before. And when this happens, you've got two main questions that you've got to answer. First of all, is it real? And second of all, how far away is it? So first they had to confirm that this thing was seen in multiple images, taken at different times and at different wavelengths of light by Hubble to prove that it was real and that it wasn't just like a cosmic ray that happened to have hit the detector or a weird artifact of the data processing. And then they had to figure out how far away it was, because with an image you compress 3D into 2D. So either it's something in the foreground, so nearby stars and nebula in our own galaxy, the Milky Way, or it's something in the background, in the very distant universe. Now we do that by taking a spectrum, so we split the light into a rainbow and get a trace of how much light at each colour or wavelength we detect, in hope of seeing a fingerprint of a specific element like hydrogen or oxygen, which glow with a unique colour of light and show up as spikes in the spectrum. The more distant an object is though, the more the light gets stretched out by the expansion of space to longer wavelengths or redder colours, and we call this redshift. And so that pattern of spikes in the spectrum acts as like a way marker for how much the light has been redshifted by. We can then work out, okay, well then how long has that light been traveling through the universe for, and therefore how far away is the object that we're looking at. Turns out when you do that for this long, thin streak, it's at the same distance as the galaxy in the image that you can see there, around about 7.8 billion light years away. And that's where things get interesting, because if this streak is that far away, then it is big. It is 150,000 light years wide, making it bigger than our entire Milky Way galaxy of 100 billion stars. So, since Van Dokkum and collaborators discovered this long, thin streak back in 2023, it fell to them to provide the first explanation, the first hypothesis to describe that. And from their data, they concluded that this had to be a runaway supermassive black hole. But what evidence did they have for that explanation? So the first thing us astrophysicists do when we have a mystery object is we look at the properties of its light. So we look at that spectrum. We look to see which elements have given off those spikes of light and how much of them and at what ratio. Like for example, the ratio of the amount of oxygen to hydrogen. Now it takes a lot of energy to make any element glow, but it takes a lot more energy to make oxygen glow than it does hydrogen. So normally galaxies are brighter in that hydrogen spike than they are in the oxygen spike. But if you have a very energetic process, then you can end up with a much brighter oxygen spike than hydrogen. Like for example, a big burst of lots of stars all forming in one place, or a star dying in a supernova, or a growing supermassive black hole. A black hole around 1 million to 10 billion times heavier than the sun, all squished into a space smaller than the solar system, which is so dense it ends up with such strong gravity that nothing, not even light, can escape when you get close enough to it, hence black hole. Now, if these black holes are growing, so if they have a disk of material that's slowly spiraling around them until eventually it will become part of the black hole and make it heavier, that material gets accelerated to such huge speeds that it also starts to glow with a huge amount of energy, giving off ultraviolet and X-ray light. It's that energy that can then hit into nearby oxygen atoms and cause them to glow. And what Van Dokkum and collaborators found back in 2023 is that all along that fuzzy line that they found, there's more of a glow coming from oxygen than there is hydrogen, sometimes up to 10 times as much. Plus, the overall ratio of the amount of blue light to red light is higher along the streak, suggesting it contains newly formed stars, which Van Dokkum and collaborators claim that light and that ratio of blue to red light is best modelled by stars that formed 30 million years ago on one end of the streak and less than 10 million years ago at the other end of the streak. So you've got something really energetic that's causing oxygen to glow, that's making lots of newly formed stars in a straight shot away from the galaxy. So Van Dokkum and collaborators in 2023 argued that the best explanation was a supermassive black hole that had been ejected from the center of this galaxy at a speed of 1,600 kilometers a second, or just under 3.5 million miles an hour. And I covered this discovery at the time in one of my Night Sky News episodes for those of you who've been around here for a while. Now, that's not as crazy as it might sound. This has actually been long predicted by computer simulations that have suggested if you have 3 galaxies that all merge together in quick succession, that all have a supermassive black hole at their center, then as the black holes try to spiral together and merge themselves, they end up interacting in such a way that one gets slingshotted out of the mix at huge speeds. Now, despite these predictions, we've never found any evidence for this actually happening, although notoriously, black holes, very difficult to observe because they don't give out any light. We can only observe the effect that they have on the stuff around them. And in intergalactic space, there's not much stuff. So when this discovery was announced by Van Dokkum and collaborators in 2023, it was met with a lot of excitement. But to make their argument more convincing that this was a runaway supermassive black hole, they had to collect more detailed data. So Van Dokkum and collaborators also recently applied for time on the James Webb Space Telescope. And earlier this year, they published their results, claiming that the Webb data confirmed their explanation of a runaway supermassive black hole, and then dubbed this object RBH1, Runaway Black Hole 1. They claimed that the end of that long, thin streak had the shape and velocities that you'd expect from a bow shot, and the wake around it caused by the supermassive black hole impacting with the gas around it. Think about a small boat moving through the water, right? At the very tip of the boat, and then the wake that it creates. This is a similar thing. You can model for that, and you can model the hydrogen and the oxygen that glows because it's been impacted by the supermassive black hole moving at a certain speed, and you can work out, okay, well then what would the velocity be of the hydrogen and oxygen in the wake? And Van Dokkum and collaborators find that they can produce a model that matches what they've observed. So they've looked at the velocities, but also looked at the ratio again between the amount of glow from different elements you get. So yes, oxygen to hydrogen, but also things like nitrogen to hydrogen as well. And they found that their model captured the overall trends, but not local variations, as they phrased it. So Van Dokkum and collaborators have claimed that with all the pieces of evidence that they've collected, that this has got to be a supermassive black hole ejected from the center of its galaxy. But is that the full story? What about the evidence in favor of an edge-on-disk galaxy instead? Because shortly after Van Dokkum and collaborators published their initial discovery of this thing back in 2023, Sanchez Almeida and collaborators published an alternative explanation that they considered more likely, that this thin streak wasn't a runaway supermassive black hole, but instead was a galaxy that we're seeing instead of face on, we're seeing it edge on. So they compared this newly discovered object with the nearby galaxy IC 5249 that we know is a disk galaxy that we're seeing edge on, and found that it has a similar distribution of light across that shape and a similar speed relative to us in the glow of oxygen, meaning that one side is coming towards us and one side is moving away from us all the time. We see that in the shift of the velocities. Not only that, but it sits directly on a well-known correlation for disk galaxies between the maximum speed of the stars and the total mass in stars in the galaxy, suggesting it's not a runaway supermassive black hole, but actually a galaxy seen edge on. But what about the new JWST data that helped to confirm Van Dockenham and collaborators' interpretation instead? Well, again, shortly after that work was published earlier this year, Sanchez Almeida and collaborators published a short research paper pointing out that although the oxygen to hydrogen ratio is high, as you'd expect from something really energetic like a supermassive black hole causing the oxygen to glow, both the nitrogen to hydrogen ratio and silicon to hydrogen ratio are very low. So the three star shapes plotted here are from locations along RBH1, whereas the coloured points in the background are just like typical star-forming galaxies and also those with growing supermassive black holes. The black lines then show the typical thresholds that we draw to separate out galaxies with growing supermassive black holes from those that don't have growing supermassive black holes. So the fact that RBH1 lies below those lines suggests that it's very firmly in just normal star-forming galaxy territory and not growing supermassive black hole territory. So it's safe to say that Sanchez Almeida and collaborators are not convinced by the runaway supermassive black hole argument. But I think that I am. My area of research is disk galaxies at large distances, but also nearby, bulgeless, flat disk galaxies that host supermassive black holes. So I consider myself an expert in what these things look like, and I'm not convinced that this is a galaxy. It has too much structure, for one thing, like more than you'd expect to see for a disk galaxy at this distance anyway. To put it another way, I don't think the light is as smoothly distributed as I'd expect. Plus, the light also doesn't fall off from the middle like you'd expect in a disk galaxy either. RBH1 has these sharp edges. And while yes, it does have low nitrogen to silicon ratios compared to hydrogen, it still sits right on the boundary that we draw for normal growing supermassive black holes in normal galaxies. But if this is a runaway supermassive black hole, then it's not normal. So I'd argue these boundaries might shift around in that case. Plus, look at the normal galaxy population in the background, right? It's not a clear-cut delineation between growing supermassive black hole and star-forming galaxy. There's a continuum of values. So there's already a big margin of error on these boundaries that we draw anyway. So personally, I'm more convinced at the minute by the runaway supermassive black hole argument than I am by the edge on disk galaxy argument. But that could all change in the future. Because the next thing we can do to try and understand these is find more of these candidate runaway supermassive black holes. Because it helps that we now have some idea of what to look for. This has shown up as a long, straight, glowing line of gas and stars at the same distance as this galaxy. That means that both human eyes will now be on the lookout for something similar, but also that classification algorithms can actually be taught what to look for. The problem then is just whether you have the right data to actually look through to find something like this again, because we know that we need a big enough telescope to actually be able to spot something this faint, which we know that both Hubble and JWST can do. But you also need a telescope to have been able to take enough images across a big enough expanse of sky as possible. But if these things are quite rare, then we also need a lot of data across a huge expanse of sky. But despite having Hubble for over 35 years, its field of view is so small that in that time, the images it's taken cover less than 1% of the entire sky. Meaning that we've only just spotted this because we happen to have been looking in the right place to find it. Ideally, what you'd have instead is have a telescope that does a survey of as big an expanse of sky as possible, taking lots and lots of images at the same resolution and sensitivity as Hubble to spot faint things like RBH1. Now, thankfully, we'll soon have just that, with the Nancy Grace Roman Space Telescope set to launch at the end of August 2026. This is Hubble's true successor, and one of its jobs will be to take a survey of the night sky, taking images with the same resolution and sensitivity as Hubble for around about a 20th of the entire sky. If there's more things out there like RBH1, then we should be able to find them with Roman. And it's finding more of these things that's crucial to understanding them, to understanding whether they are runaway supermassive black holes or just edge-on disk galaxies. With more of them, we get a spread of properties for a large group of these things, from their brightness and their color and their shape and the ratio of oxygen to hydrogen and the speed that the stars are moving at. And if we're lucky, the smoking gun evidence that would prove that this is a runaway supermassive black hole is if we would find any ultraviolet or X-ray emission at the ends of one of these things that was coming from the material spiraling around the black hole. That's what would convince me, at least, that finally, after decades of predicting they should exist, we finally found an ejected supermassive black hole. And then they had to figure out how far away it was, because either it could be... Wait for the motorbike to go past. For continuing the science. Oh my gosh, it's so hot. You can tell how hot it is because I'm just in every single piece of linen that I own at the minute. And by my trusty little thermometer in the background. What is it? 26 degrees apparently in here. Supermassive black hole. Do you think that Muse would like do a version 2 of their song of just like, not just supermassive black hole, but ejected supermassive black hole? They can have that idea for free.